Bismillahirrahmanirrahim. As you guys have an idea, from the last few lectures, we are discussing wet lab chemistry tests for the identification of a given unknown compounds. That very respect I started off that once you are given an unknown compound, you guys need to start from the litmus solution test. The litmus solution test actually confirms the nature of the compound. It suggests whether the given compound is acidic in nature, or the given compound is basic in nature, or the given compound is neutral in nature. So if the litmus solution suggests the given compound is sort of an amine, then I told you sort of a basic compound. If the litmus solution confirms the given compound is a sort of an basic compound, then one thing that should come to your mind is that the given compound may be an amine. Then in case of amines, I have explained in detail that those could be confirmed by three tests: diazotization test, okay, then the next was carbyl amine test, and the third was Hinsberg test. These were the tests which helps you to identify the given unknown compound if it is an amine, if it's a basic in nature, and the line of action was determined by the litmus solution test. Now I'm to move today into the next category. If you start with the litmus solution test and the litmus solution suggests your given compound is some sort of a neutral entity, then the neutral compounds are supposed to be neutral compounds are supposed to be, number one, they could be carbonyl compounds, or they could be carbohydrates, Though two options could be possible, and those options like the presence of carbonyl compound, the presence of carbohydrates. When it is possible, once your litmus solution has confirmed that the given compound is some sort of a neutral compound, So let me start this category, the neutral compounds. And in case of neutral compounds, let me start the category number one, the carbonyl compounds. How one can identify the presence of carbonyl compound? What is the basic test that helps us to identify the presence of carbonyl compounds? That is very much known to you guys. That is called 2,4 DNPH test, 2,4 DNPH test. That's what I'm going to start today. 2,4 dinitrophenyl hydrazine test. The exact name for the test could be 2,4 dinitrophenyl hydrazine test. That is the test that actually confirms the presence of carbonyl compounds, and those carbonyl compounds actually, it could be aldehyde, or it could be a ketone, or it could be ketone. These two buddies fall in this category, So 2,4-DNPH test in fact confirms the presence of aldehydes and ketones. How it identifies, how it helps to confirm, that's what we are going to discuss now. How you perform that 2,4-DNPH test, you are supposed to start by pouring in 2,4-DNPH reagent into the test tube. You need to put that in. What is this actually? 2,4-DNPH reagent, what is this? It is actually 2,4-DNPH plus few drops of sulfuric acid dissolved in ethanol. If you have dissolved the reagent in ethanol and few drops of sulfuric acid has been added, that will be called as 2,4-DNPH reagent. You are supposed to get that, pour that reagent into the test tube. Then as the number 2, you may put in unknown carbonyl compound, mean aldehyde or ketone. You should put that in. After shaking, you're supposed to get orange colored precipitates. Precipitates are supposed to settle down. They are supposed to be of orange color. If you find orange colored precipitate settling down at the bottom of the tube, it means the starting unknown compound is aldehyde ketone, mean the carbonyl compound is present. So this is how the formation of precipitates confirms the presence of aldehydes and ketones. This is the basic idea behind the 2,4-DNPH test. Let me recall that. Let me rebrief you again. How the 2,4-DNPH test is performed. In order to perform the 2,4-DNPH test, you are supposed to have a 2,4-DNPH reagent. What is that actually? That is 2,4-DNPH has been dissolved in ethanol as a solvent, and a few drops of sulfuric acid has been added into the solution, and that will be called as a 2,4-DNPH reagent, 2,4-DNPH solution. And then you need to use the solution for the identification of the unknown compound. Then you need to put that DNPH into the test tube. Then you can put in the unknown compound, which you are supposed to be a carbonyl compound, because you have already performed litmus solution, which confirm the given solution is a sort of neutral entity, and if it is a neutral, mean it could be an aldehyde or a ketone. So you can move this way. After putting these two in the test tube, you are supposed to rinse it. You need to shake it well. If the orange color precipitate settles down at the bottom of the tube, it confirms the compound was carbonyl compound. It can be an aldehyde, it can be a ketone. This is how the test is performed. However, what is the chemistry behind this test? When we put in the 2,4-DNPH test and we put in our carbonyl compound into the test tube, and then some precipitate settles down at the bottom, it happens actually inside the test tube, who reacts with 2,4-DNPH and how it reacts, what is the cause of the formation of the precipitate? That is the actually chemistry involved, the chemical reactions involved in this test. Let me discuss those. This is the reagent, this is the chemical formula of the reagent, that is 2,4-DNPH reagent. 2,4 dinitro. Two nitro groups are present over here, NO2 and NO2. Two nitro groups are present here. 2,4-dinitrophenyl hydrazine. This is the hydrazine group. So this is the reagent actually that is involved in the reaction. How it reacts, we have an idea. Let's say we have some sort of aldehydes or a ketone which actually participate in the reaction, as this test is specific for aldehyde ketone. Let me start with having a ketone over here. So what is supposed to happen, as we have an idea, amines do carry lone pairs, aldehyde ketones undergo nucleophilic addition reactions. It moves up. So what is supposed to happen over here? You are supposed to see a sort of reaction like this. I can write it the way. It could be 2,4-dinitro. It could be right this way, This lone pair has reacted at this the carbon, so there is a bond between this lone pair nitrogen and the carbon. This double bond has moved up in the form of a negative charges, and this nitrogen at the moment carries 4 bonds, so it is supposed to carry a positive charge. As we have an idea, in the 2,4-DNPH reagent, we have put in few drops of sulfuric acid. Protons are available from the sulfuric acid. Those protons can come over here to neutralize the negative charge on the hydroxyl, to make a hydroxyl, an alcoholic functionality attached to the carbon, So this will be a sort of the alcohol produced from the aldehydes or ketones. As we have an idea, in order to neutralize this positive charge, once we have a bond between nitrogen and carbon, there is a removal of water, generating a double bond between carbon and nitrogen. That is called an imine formation, So I can do the same. I can write the product at the same. So we will have a nitrogen, over here, and we will get a double bond between nitrogen and this hydrogen and hydroxyl group, and H from the nitrogen will be removed in the form of water. Definitely this nitrogen carries its proton, no issues to it. So this is the final product, that is called as an imine. I've given you lecture on the imine formation in your classes. So this product, when it is generated inside the test tube, this body that goes to settle down in the form of precipitate. So if the given compound is an aldehyde ketone, definitely it will produce the corresponding imine. So imines are supposed to produce the precipitates, colored precipitates, which settles at the bottom of the tubes and confirms their presence. If you don't have aldehyde ketones, there won't be a formation of imine, and then that's why those imines, if they are not present, you won't see any formation of the precipitate at that time, So this is how the presence of aldehyde ketones is confirmed using 2,4-DNPH test, which actually involve a reaction between an amine and aldehyde ketone. We have an idea, aldehydes and ketones do undergo nucleophilic addition reactions. Aldehyde ketones undergo nucleophilic addition reactions and produce corresponding alcohols as it was produced in the first step, Those alcohols are okay if your nucleophile is other than amines. However, if we have a nucleophile in the form of an amines, they produce alcohol at the step number 1. Then they undergo elimination of water as an extra step, producing imine as the main product. That's the speciality of the amines only. So amines act as nucleophiles, do react with aldehyde ketones as per the routine of, as per the normal nucleophiles. However, once they are amine, they undergo one extra step, eliminate one water molecule, resulting in the formation of imines, and those imines actually are conformed during this test, which is specialized for the conformation of presence of carbonyl compounds. So this is the basic chemistry, basic idea behind the 2,4 DNPH test. Let me give you a bit another practical example how one could expect the product formation. Let's say we have given you benzaldehyde. We have given you benzaldehyde for the identification purposes. This is a benzaldehyde, and let's say at the same time you are to use 2,4 DNPH. This is supposed to be 2,4 DNPH because it's a number 2, 3, and it is supposed to be here. Sorry, so it is supposed to be here. 2,4 DNPH test are usual, so it is supposed to react over here. So what do we expect actually? This moves in the form of O negative. We usually don't write H, or we can write the other way. We have nitrogens having 2 protons there. We have another nitrogen, and then we have rest of the molecule as this one. One of the protons may move from here to here, that's also possible. One of the protons shift from here to here because there is a positive charge on the nitrogen. Yes, that could also be the explanation. So once we generate over here, it will become an alcohol. That's a proton that is of the starting aldehyde. Then we will have a nitrogen with 1 proton only, because one of the proton has been moved up in order to utilize the positive charge, so there is no more positive charge over here. So then the rest of the molecule, it is supposed to look like this one. Then, as we have discussed, a bond between carbon and nitrogen, if they carry hydroxyl group and protons, they remove one of water molecule. They remove one water molecule and give us here is nitrogen, here is nitrogen. We will have the nitro components around. So there is a double bond between this carbon and the nitrogen, which is in fact is considered as imine. So imine formation will happen, a corresponding amine starting from the benzaldehyde. This is how the product is supposed to look like. This product will form inside the test tube, and it will be represented or appeared in the form of precipitates. This can happen in this way. So you will find this imine in the form of precipitates at the bottom of the at the bottom of the test tube, This is how it happens. Let's say if you have a starting ketone, let's say we have this sort of a body, very famous, easily available in our labs, that is called benzophenone, Benzophenone, we often give this body to you as an unknown organic compound and we ask you to identify this one. So it's a benzophenone. As usual, you need to start with the litmus solution. The litmus solution will confirm, yes, that the given compound is a neutral. If it is a neutral, then two things will come into your mind, either a carbonyl compound or a carbohydrate, So at the outset, we need to hunt for the carbonyl compounds, and those carbonyl compounds could be confirmed by 2,4 DNPH test, what I am discussing at the moment. And I have just explained the mechanism, what happens, what is the exact chemical reaction that happens inside the test tube that helps you to identify the given unknown carbonyl compound, So once it's a benzophenone, similarly, what is supposed to be, it has to move up. Pretty simple reactions I've explained to you guys in your previous lectures. So this is how nitrogen, this one having positive charge because it has 4 bond at the moment, so excess bond formation is supposed to carry positive charges. So this is something. Then one of the proton will shift from here to here because one has to neutralize the negative charge. As we know, the aldehydes and ketones do react with amines or any nucleophiles, and they produce corresponding amines, So this is corresponding alcohols. Excuse me, I'm to explain it again. Aldehydes and ketones do react with nucleophiles under nucleophilic additions, and they produce corresponding alcohols. So this is how it is supposed to look like this, because it's a sort of an alcohol. Then it has lost one of the proton which has moved up, so as a result it got neutralized, no more positive charge is there. That is supposed to be at the moment. Then, as I've given you clue, I've explained to you, the amines are a special class of nucleophiles. When they react with aldehyde and ketones, at the first step, they do undergo nucleophilic addition and produce corresponding alcohols as usual. But after the formation of alcohols, they eliminate water molecule from the alcoholic product and produce the final amines. So what happens? This hydroxyl proton is removed. So what happens then? We have 2 benzenes, 2 phenyl groups around. Here is nitrogen and carbon, a double bond has been formed, and then we have a nitrogen which carries one proton only at start, right from the start, and that remain till the formation of the final product, and then you are supposed to get this 2,4-dinitrophenyl phenyl substitution as such. So this will be the amine. This will be the amine again. This amine product has been generated from ketone, and which is in this case is benzophenone. So if you start from aldehyde or you start from ketone, the product is supposed to be a sort of an imine, and thus imines are supposed to be colored precipitates, orange colored precipitates, and they settle down at the bottom of the tubes, and the appearance of the precipitates of the imine represented that your starting compound was some sort of an aldehyde or a ketone, because as a part of the test we have added 2,4-DNPH. This body has been added by ourselves, so we have an idea about its chemistry, about structure. So if this has happened, this has been produced at the end, then means it's already present from our side. So it would be the given unknown, some sort of a carbonyl compound which has undergone nucleophilic additions, and then corresponding imine has been generated after an elimination of water from the alcoholic products, and the colored precipitate would represent that the carbonyl functionality is present. So this is called 2,4-DNPH test. Pretty easy to understand and pretty easy to perform. This is how you can identify given unknown carbonyl compound. Now the carbonyl compounds, as I've told you, both aldehydes and ketones show their presence when they are tested using 2,4-DNPH test. If we want to know whether the given compound is aldehyde or a ketone, as it is a ketone, in my previous explanation over here I have used benzaldehyde. So in case of benzaldehyde, in case of benzophenone, the product imine has been generated with the colored precipitates. So if one is interested to find out the exact nature, exact compound, whether it's an aldehyde or whether it's a ketone, definitely he or she has to differentiate between the two. So first step was the confirmation of carbonyl functionality, aldehyde or ketone. Now if you want to differentiate whether the given compound is an aldehyde or it's a ketone, we need to apply another test that can distinguish between aldehydes and ketone, whether the given compound is an aldehyde, whether the given compound is a ketone. That will be the topic of my next lecture regarding the wet lab chemistry. That test will help us to identify, help us to differentiate the exact nature of the carbonyl compound. Let me get back to this one again. So once we started with the litmus solution and we came to know that the given compound is a neutral, one thing come to our mind that the given compound could be a carbonyl or a carbohydrate. So for carbonyl compounds we applied 2,4-DNPH test. Through this chemistry we are supposed to get colored precipitates. If we observe the presence, the formation of colored precipitate means the aldehyde ketones are present. Let's say if the precipitates are not formed, means this body is present but this body is not present. Aldehyde and ketones are not there, something else is there. What that could be? Means that is not a carbohydrate, that is not an aldehyde, not a ketone, not a carbonyl compound. Then what it could be? Definitely it is going to be a carbohydrate. Then how the carbohydrate exactly be confirmed, that will also be a topic of my next lecture. The confirmation of carbohydrates, similarly the confirmation of aldehyde and ketone, the distinguishing test that can distinguish between aldehyde and ketone, that will be explained to you guys in my one of the next lectures, inshallah. So at the moment what I've done, I've tried to clarify the reaction that happens inside the test tube that confirms the presence or absence of carbonyl compounds is 2,4-DNPH. I've tried to explain the chemistry, what is the reaction in it and how the reaction is performed. I do hope you people have got the idea about the 2,4-DNPH test. Try to apply the test on different aldehyde and ketone, and let try to see the difference in the product. You will see only the difference will be the difference of the substituent of the starting material, and those substituent will be remain the same in the product, but there won't be a difference in this whole area. No difference, no effect on the nitro groups, no effect on this imine bonds, they are supposed to remain the same. What is going to be the difference? Difference will be the substituents on the carbon that is involved in imine, and that is will depend upon the nature of the starting material. The rest will be the same. So try to apply this test theoretically as well as in your lab on 2, 3, 4 different aldehydes and ketone, and see what is the difference between the product, what could be the difference. First try to chalk out the reaction mechanism and the product on your notebooks, and then you are supposed to perform those in your lab and see what is the difference in the test tube once you have used benzaldehyde, once you have used benzophenone, once you have used acetaldehyde, or you're using any other aldehyde, or you're using any other ketone. So this is all about for DNPH test. I hope I've tried my best to clarify the concepts regarding this test. Even then, if you have any question in your mind, you are welcome to put your questions in comments area, or you approach me through WhatsApp. I will be happy to respond at the earliest convenience, inshallah. Thank you very much for your attention. Assalamu alaikum.